Great. Yeah, welcome. This is the third part of the 7-part series of the mini workshop on spatial phylogenetics. And today, this afternoon, I will be talking about the spatial data associated with spatial phylogenetics and cleaning and preparing those data for analysis. So there is a reason why it is called spatial phylogenetics. That is, we are talking about the occurrences of the taxa that you are working with, or the studied set of organisms that you are working with, or the area that you are interested in. And so for you to be able to do this analysis, you will need a phylogeny, which is what Brent has been talking about the last two sections. So you need a phylogeny where all the tips of that phylogeny correspond to the area or correspond to the group of organisms that you are interested in. And then you need the occurrence data. And again, this is taxonomic free. That is, it could be at the genus level, it could be at the species level, it could be at any level. So, but you need the occurrence of these organisms on the tips or the terminals of the tree. And of course, many of us probably know that there are a lot of issues that may arise for either of these two components. Of course, for example, we don't have a phylogeny that connects virtually every organism on Earth. There are many organisms that have gone into extinction. We don't have information for them either. We have information for a few, what we call the fossils that we use for calibrating chronograms. But for a lot of occurrence data we have in Herbaria or online databases, we have a lot of issues with them, and that is what I want to focus on. So where do we get occurrence data for the taxa we want to work on? The very first place you want to think about is the herbarium or the museum in terms of animals, organisms. But for plants, the very first place where you want to think about is the herbarium. And this is one of the reasons why we, as plant scientists or as botanists, we are really concerned about funding for herbarium, because this is where we have a wealth of knowledge and information on our plants. And we need, as much as we need to keep libraries of books and where we get information or knowledge on various things, we need herbarium to be able to continue to retain our botanical knowledge and experience for a particular area. Of course, various institutions have Herbaria, and many of them have become clustered into different networks. For example, we have the Consortium of Californian Herbaria, what is called the CCH, and we have the Intermountain Herbarium network and various herbaria all over the country. And again, there are also international herbaria. And the reason why I bring this up is because the collections, the voucher specimens that are being managed or held by this herbaria, many of them are getting funding, and there's still a lot of need for funding to be able to make those records available online. So you don't have to travel to Texas, for example, if you want to work with flora in that region. You can go on the Herbaria Network Touch, for example, and you'll be able to get information about the collections or the native flora in that region. And the same goes for other parts of the country and even the world. So we have these consortia and these Herbaria networks where occurrence records of different taxa are made available. And then at the international level, we have the GBIF, which is probably the most common of them all here, the Global Biodiversity Information Facility, which has capacity for holding many of the occurrence records for many taxa all over the world, both in their native and naturalized ranges. That is what we would call the artificial ranges, especially places like in botanical gardens and things like that. For those who are working with animals, they often go to the VATNet database. We have the plant list, since we're working mostly with plants, and this is a botanical workshop, so we're going to focus more on the plant aspect. So we have various websites and various databases that have publicly accessible databases of occurrences of plants that we want to work with. But again, like I mentioned, there are many issues that can arise when we want to work with this occurrence data for the plants we want to work with, which are the terminals on the phylogeny that we have. For example, there are cases whereby old names are being used for those occurrence records and they have not yet been cleaned out. There are cases whereby the names may be misspelled, or some even use different authors or publishing authors for those names. Or in many cases, some people might think, oh, wow, I just discovered a new species, not knowing that that species is already discovered somewhere else. And so there are synonyms available for them. And so there's a lot of taxonomic issues that could arise because of that. Some of the Herbaria records we have also dates all the way to 1700, 1800, and taxonomy has changed over these decades and centuries. And so sometimes there are limited capacity to go through the millions of records to begin to clean those names. And so one has to be aware or conscious of these taxonomic issues that may arise in just going on GBIF data and just downloading the data, because we have to be very careful about the taxonomic issues associated with the occurrence records that we want to download. So how do we correct or deal with these issues? For example, we have the International Plant Name Index, which is one of the many options for looking or resolving taxonomic names of organisms that you are working with. We have Plants of the World online that you can use to check the names. We have the World Checklist of Vascular Plants. We have the Plant List, and we have the Taxonomic Name Resolution Service, as well as the World Flora online. This list is not exhaustive. There are many other databases out there that people can use to check the names. And if you are somebody who is maybe a little bit, you are good with data analysis, you can upload all your names into the website of these organizations and just run that list, and then it will tell you, oh, well, this name, this is the synonyms for this name, or this is the accepted name for this organism and taxon, and so on and so forth. You can even do that in R as well. For example, if you are working in R statistical software, Plants of the World, especially, and the World Checklist of Vascular Plants, the backbones of those databases have now been used to create R packages that you can download and you can use to check the names of the plants you are working with without having to be doing them manually. We can just put all of them in our software and run them, and it will do everything all for you and clean your data for you, especially at least the name part, it will do that for you. Plants of the World online is more like international, and then of course the World Checklist, those are more global. If you are working with North American flora, some experts have suggested that the World Flora online tends to have more comprehensive data for the North American flora than for the rest of the world. So it also depends on the region where you are working with, and what is available and how clean those data are. Then, so when we are talking in terms of occurrences of data, this is a very important attribute or biological attribute, which means a lot of things. So when we download data of occurrences of data or keeping those records in the Herbaria, what do they represent? They represent, or we can use them to infer the relationships of those taxa with the prevailing environmental conditions in the locations where they are found. And this is the basis for species distribution modeling, for example, or the ecological niche modeling, because we are making the assumption that this plant is found in this region because it has ecological affinity or tolerance for this particular microclimatic or environmental conditions in that area is favorable for that plant, and that's why the plant is found in that location. And oftentimes, of course, plants don't exist on their own. There are other taxa there, plant or non-plant taxa, and they coexist together. And so we can use the occurrence of data to also explain something about their coexistence or their ecological relationships with other plants and animals in that area. We can also say something about their dispersal capacity. Many plants, we call them rare plants. Rare plants, not necessarily because the range of ecological conditions that they can survive in is small, but sometimes it could be because they don't have the necessary traits or the capacity to disperse to other regions that have similar favorable environmental conditions. And so we can say something or discuss something about the dispersal capacity of these organisms given their existing real-life niche or occurrences. And of course, we can, based on dispersal capacity, we can also say something or describe something about the functional traits that are associated with the persistence of these organisms. For example, in a saltwater marsh, you will not find, there are only certain lineages or certain plants that can only survive and grow in a saltwater marsh. And or even in a freshwater marsh or in a wetland. This means that those plants must have traits to be able to tolerate excess water or high salinity, which many plants don't have. Only certain groups of plants have those capacity. And so we can use their distribution or the distribution of plants to say something about the traits that are associated with the persistence in those particular environments. And this has a lot of, and distribution of taxa has a lot of conservation implications, as we all know that there's a lot of prioritization for rarity or endemic plants, which could be relative endemism or absolute endemism, as Brent has described earlier. And this also could have evolutionary implications, especially when we talk about endemic taxa. Is it that they were previously widely distributed and their range is now shrinking, or is it that they evolved more recently and they are yet to expand fully throughout their entire range? There are a lot of evolutionary biology questions that could be answered given the distribution of taxa. So this slide helps us to understand that the distribution of taxa is a very important biological attribute that can be used to answer a lot of questions or for us to understand a lot about these organisms, both from the ecological or evolutionary or even conservation perspective, and of course, biogeography. So, talking about the locations of the plant, then we're not just talking about those occurrences, but they have to be represented as geospatial data. And so when you say, for example, you have a spreadsheet that has all the latitude and longitude or information about the location of a plant, they're just numbers. But those numbers need to be transformed into a data format for whatever program you are using to say, yes, these are just not numbers, but they represent locations on the face of the earth. And in that case, then they are not just occurrence records, but they are now geospatial data. And for anything to be called a geospatial data, they must have three properties. They must have attributes, that is description of the location. It could be in the canyon in between two mountains, or it could be 5 kilometers east of one particular city or something like that. So you must have description. That is why when we go collecting data or go for field surveys and you collect herbarium records of partial specimens, you need to have metadata, a full of vivid description of the location where you collected those plants. And then you must have a coordinate reference system. And so this is where GIS again comes in. And when we talk about a coordinate reference system, we know that we are in a round earth, or a spherical or somewhat slightly spherical earth. But when we look at the earth, or when we print out a map, we are looking at a 2D map or a flat map. And so the coordinate reference systems are mathematical formulas that help us to translate the geospatial data in a round earth onto a flat map without in such a way that we want to minimize distortions on that map, so that we're not just picking a map, a point in North America, and then when we make mistakes, it could show you that that point is somewhere in the middle of the ocean. And then we begin to scratch our head. Something is wrong somewhere there. And then, of course, the coordinates, which is the longitudes and the latitudes. So on a graph, think of it as a graph. The longitudes is on the x-axis and the latitudes are on the y-axis, just like you will see on a Cartesian or a 2D object. And so again, there are two ways of representing the locations on the map. We have the geographical coordinate system and we have the projected coordinate system. And I will not go into details of each of these, but each of them have different mathematical formulas that are used for representing those coordinates on the map, and it also depends a lot on your study area. For example, if you are studying the entire globe, or you are studying the North America or at the continental level is where your studies are, there is a better coordinate system to use, for example, as compared to if you are working in a very small study area. But we'll not go into details of this, as there are so many philosophical variations about what coordinate system to use versus the other. And then one thing also to mention is that there are also geocoding software, especially if you don't have the coordinates. For example, samples that were collected in the 1700 or 1800, and we don't have GPS units at that time, and people just have description of those areas. If those attributes, the description of the location of those areas, are accurate enough, then we have several geocoding software out there that we can enter those locations in them, and they can give you the likely coordinates of those locations. And that is sometimes we call it geocoding or geolocation or georeferencing of locations. So again, choosing the right coordinate system, this is not a trivial issue. People take classes to be able to understand there are several coordinate systems, and there are different projection ways of doing projections as well, and each of them have their pros and cons. But one thing that always happens to them, in fact, none is perfect. For each of the coordinate system you choose to use, it always brings distortion either in the area, the shape, or the direction of the points that you are working with. So we always recommend using the right coordinate system, and I say the word right in quote, such that you want to choose a coordinate system that minimizes those distortions. So for example, if your study is at the continental level, say you're working with the entire North America, it is usually advised to use the Albers equal area projection with that is, you're using a projected coordinate system that is, for example, UTMs, the Universal Transverse Mercator. And what the Albers equal area projection does is that if there's any distortion anywhere, that distortion is spread across all of the locations of that study area, such that there's no distortion somewhere and there's accuracy somewhere. So if there's going to be if there's any distortion, that distortion is equally distributed across the entire study area, such that it will not affect the measurements or the data, the locations that you are using. Also, I've heard colleagues in the Scandinavian countries say, for example, if you are working in areas close to the poles, you should use the geographic coordinate system instead of the UTMs or other projections. Again, there are software available that you can enter your data into those software, input your data into the software, and choose a particular projection or reference coordinate system, and then it can tell you how much of distortion is there given the projection you use, and you can play around with many projections and decide on the best one for your study area, given the distortions that are shown in that software. Missing spatial data, again, as I said, if you have accurate location of the data, you can use some software to georeference those locations. If you're not working with a large study area, then we have a lot of local citizen botanists and scientists who will be really interested in doing field surveys to be able to ascertain those locations in the map, or perhaps maybe they are collections taken in 1700 and that area has been built up, has become a city. And so you might want to exclude those areas from your map. There are also taxonomists who are expert in specific plant families, and they can help you ascertain those some certain locations to say, well, yes, I studied all the taxa in this family, and I know for a fact that that location is questionable and things like that. They can help you, or you might just want to exclude any location that has missing spatial data from your analysis. For example, I'm working with some data that I downloaded from GBIF recently, and I felt like, well, I have thousands and thousands of data which have no spatial record or coordinates for them, and they are found in other parts of the world. I'm not going to travel to other parts of the world to go and ascertain those, and I don't have enough time to be looking for experts in those areas. I might just exclude them from my data analysis altogether. And so these are some of the issues that we often encounter, especially when we are working with data. And sometimes this, for example, if you're working with like thousands and thousands of records, or you're working in a huge study area, especially at the continental level for studies that have already been conducted by Brent and other co-authors, then these issues have to be dealt with. In fact, in reality, when you are working in spatial phylogenetics, the data cleaning itself takes longer time than the analysis. The analysis could be conducted within 1 week or 2 weeks and you'll be done with it, but it is the data processing and cleaning that takes a longer period of time in itself. But I hope this helps you, or helps all of us to understand the issues that we have to always be constantly aware of when we are dealing with spatial phylogenetics, especially with data assembly, processing, and cleaning. And at this point, I will end this part and I will open it up for questions.